Section 10.2, find arc measure. A central angle of a circle is an angle whose vertex is at the center of the circle. If the measure of angle ACB is less than 180 degrees, then the points on circle C that lie in the interior of angle ACB form a minor arc with endpoints A and B. The points on circle C that don't lie on the minor arc AB form a major arc with endpoints A and B. A semicircle is an arc with endpoints that are the endpoints of a diameter. Minor arcs are named by their endpoints, so AB. Major arcs in semicircles are named by their endpoints and a point on the arc, ADC, so that you know that it goes from here to here. Because if we named it AB, how do we know if we're talking about this arc or this arc? So the minor arc, AB, major arc would be ADB. Okay, so the measure of a minor arc is the measure of its central angle. And then you see this that represents the measure of arc AB. The measure of the entire circle is 360 degrees, and a major arc is the difference between 360 degrees and the measure of the related minor arc. The measure of a semicircle is always 180 degrees. Okay, so in this example, we want to find the measure of arc DB, DAB, and ADB. So DB is this arc right here. The central angle is 135 degrees, so the measure of the arc is going to be 135 degrees. To find the measure of DAB, what we're going to do is take 360 and subtract off that 135. And that's going to give us 225 degrees. And then to find the measure of angle of arc ADB, that is this one here, well, AB is a diameter, so arc ADB has its endpoints on a diameter, so this is 180 degrees. Two arcs of the same circle are adjacent if they have a common endpoint. These would be two adjacent arcs. It would be BD and DA. They have that common endpoint D. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So we could find the measure of this arc if we knew what this arc was and this arc was. We could add them together to find the whole arc. Okay, so we have a result of a survey about the ages of people in town are shown. We're going to find the indicated arc measure. We want to find the measure of RV. So that is this arc here. Which is going to be 60 degrees. Then we want to find the measure of arc RST. So that's going to be from here to here. So we're going to take 100 plus 30. We're going to add the two arcs together to get 130 degrees. Then we want to find the measure of arc RVT. So RVT starts at R, goes to V, and then goes to T. So it is everything except this 130. So what we're going to do is take 360 and just subtract 130. That'll be the simpler way to go. You could also do 60 plus 80 plus 90 to get there. And that's going to be 230 degrees. And then finally, we're going to find the measure of arc UST. What's this? Okay, so U, S, and then T. So you have to follow it around that way. We can't go this way because T would become before S. And S has to be before T. So that is everything except this 90 degrees. So we're going to take 360 degrees and we're going to subtract off the 90 degrees. And that's going to give us 270 degrees. So two circles are congruent circles if they have the same radius. Two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or of congruent circles. Okay, so in this example, we're going to tell if arcs CD and EF are congruent. We have three different examples. Okay, so for the first one, we want to know if arcs CD and EF are congruent. Well, they're both the same measure. They're both going to be 45 degrees. And they're in the same circle. So, since they're in the same circle, the measures of the arcs and the measure of the arcs are equal. Arc CD is congruent to arc EF. For part B, the arcs are equal because this arc is 110 degrees and this is 110 degrees, but they have different lengths of radii. They are not in congruent circles, so they are not congruent here. So I'm going to write not congruent by putting the congruent symbol and crossing it off. So then here, they're in the same circle. And since these angles are vertical angles, the arcs are going to have the same measure. So therefore CD, arc CD, is going to be congruent to arc EF.